Problem 103 is probably one of my all-time favorite problems from this section. We are looking at the graph of the second derivative, and we're being asked to find information out about the graph of f. So this is really not a new concept, but it is a new look to the problem because what we're looking at here is the graph of the second derivative. Okay, so let's identify what we already know about the graph of the second derivative. The second derivative, when the graph of the second derivative is under the x-axis, f double prime is negative. Okay, so that happens on the interval from -4 to -3. Okay, what we also see is that f double prime is positive on the interval from -3 to +3, but also on the interval from 3 to 4. Okay, we wouldn't say that it's positive from -3 to 4 because it does equal 0 right here at these values along the x-axis. So f prime, double prime is equal to 0 at x equals -3 and also at x equals +3. And the question is, do we have inflection points at those values? Well, we don't have inflection points at both of those because we only have a change of concavity at this value here when x is equal to -3. And so we'll get to that. And as I just was analyzing the graph of f double prime, and as I look over here at part A of question 103, I see where is f concave up. So from the initial analysis of f double prime, we can see clearly that f is concave up. As long as you understand that f is concave up when f double prime is positive and concave down when f double prime is negative, then we can clearly see that, as we just said, that f double prime is positive on the intervals from -3 to 3 and also from 3 to 4. Okay, f is concave down, in which f double prime is negative. As we said, that occurs between the x values of -4 and -3. Okay, and then again, a change in concavity, meaning f double prime changing sign and also the function exists at that value, would be where part C, we have an inflection point on the graph of f at the x value of -3. So when x is equal to -3, we have a change in concavity, f double prime changes sign, and that's all we have to say about that. And as far as part D goes, let's not worry about that. That's a bit of an advanced question here, so we're not going to worry about part D. Okay. Now, for problem number 104, we'll go ahead and switch gears here. We're given a function, but we've got an a and a b. Another neat question that we have to do a little bit of analyzing with. If we want to know where the local minimums are and the points of inflection, well, we're going to be incorporating the derivative of f of x, and so f prime equals 3x squared plus 2ax plus b. So there's the derivative of f. We don't know what a and b are yet, but what we do know is that the second derivative of f is equal to 6x plus 2a, where a and b are constants, and it doesn't necessarily say that, but you have to assume that that's what that means. So find the values of a and b. Well, if f double prime is equal to 6x plus 2a, and if you look back at the question, it says there's a point of inflection at -1, then f double prime at -1, since this is a polynomial function, we can see that it's a polynomial, f double prime at that -1 must be equal to 0. And so if we replace x with -1, we get -6 plus 2a, and that's equal to 0. And then 2a then would be equal to +6. So a is equal to 1/3. So we do have our first value of a or b. So we have a equals 1/3. And then when we replace a with 1/3, we can see that we get f prime. Now where am I going to do this? Here. So I'm not finding a whole lot of room here, but I'll try to squeeze it in. I'll use a different color. F prime then, oh, pardon the interruption, I just paused the video, I don't remember what I was saying, but now that we have f prime, or we have a equaling 1/3, we can replace a with 1/3 in the f prime equation. I was looking for some room here. So we do have f prime, let me do this in green, f prime is equal to 3x squared plus 2 multiplied by 1/3, so plus 2/3 x plus b. And it says we have a local minimum at x equals 3. So if we have a local minimum at x equals 3, then that must mean that f prime of 3 must be equal to 0. So if we replace x with 3, then we get 27, so 3 times 3 squared, so 3 times 9 is 27, and again we're replacing x with 3, so plus 2/3 times 3, so we're going to put a 3 there and a 3 there. 2/3 times 3, the 3's are going to cancel, and we get plus 2, and then plus b is equal to 0, and we could see we have 29 plus b is equal to 0, so b therefore must be equal to negative 29. Kind of an interesting problem, nevertheless. If you don't take the right direction there, it could get a little bit interesting. But normally, when you get problems in here in calculus where you're supposed to solve for an a or a b or both, typically the math works out nicely, and like it did in this case. So if you start going in a crazy direction, back up, take a deep breath, go on to another problem, and then go back and tackle it when you have a little bit more time. And sometimes the numbers just get more clear, and when you have a little bit more time and you're a little bit more relaxed. So don't freak out when things start going crazy on you. Just take a break, go on to another problem, and don't waste time on something that you might, well, don't waste time on any one problem. Don't spend too much time on any one problem. So anyway, there you go. See you in the next video.